We're doing Honors Algebra 2 Pre-Calculus, section 6.3 in Pre-Calc, which is vectors in a plane. We're going to talk about direction angles. So let u be a unit vector, meaning that its magnitude is 1, so magnitude of u is 1, at an angle theta from the positive x-axis. Remember that when we measure angles, a positive angle means going counterclockwise, so in this situation, theta would be a positive angle. If I had gone into quadrant 4, my theta would be a negative angle. All right, so u has this. The u vector in component form is some x and then some y, right? That's what we know. So if I want to find this angle theta, right, there are a couple of different ways that I can do this, right? So we're gonna talk about a way to find theta, which is fine, and we're also going to talk about another way to write this component form, essentially using the information we have about theta. So if we do a little bit of SOHCAHTOA, right? So SOHCAHTOA, which is our basic trig stuff that we learn in geometry, right? The sine of an angle, so the sine of theta, is the opposite, which would be y, on top of the hypotenuse, but we know the length of the hypotenuse is 1 because this is a unit vector. So what that tells me is that my y value is the sine of theta, right? And similarly, ka would be cosine equals adjacent, which is x, over the hypotenuse, which again is 1 because this is a unit vector. So my x coordinate of this vector, my x component, right, would be cosine of theta, right? And then TOA says that the tangent of theta is the y on top of the x. Now what that tells me is if I need it, it tells me what theta is, because theta is the inverse tangent of y on top of x. So those three formulae that we get are pretty basic. They're from SOHCAHTOA, but they're going to be relevant. So what I want to point out from these two is that another totally acceptable way to write u in component form would have been cosine theta, comma sine theta. So if what I was given was cosine and sine, if what I was given was the theta, then I could write this as cosine theta, comma sine theta. Now, an interesting side effect of this, right? Let's talk about what happens if this is not a unit vector, right? So let's say I draw another situation, right? Let's say I draw some other situation where now I have some vector v, right, which still has that x coordinate and that y coordinate and that theta, but now the magnitude of v is some other number, right? That's the length of v. Well, that means that I can also use this same rule to write vector v, but instead of having this magnitude of 1, what I want you to notice is everywhere that these were 1s because u was a unit vector, well, now there'll be a magnitude of v. So what's going to happen is now my y is going to be the magnitude of v times the sine of theta, and my x is going to be the magnitude of v times my cosine theta. So another way to write v, in addition to writing it as the component form x comma y, would be to put the magnitude in front and then put it as a cosine comma sine. So this is the way that you'll sometimes see that you'll be given a magnitude and a direction and you could write the vector in component form. So what we're going to do in our next round of examples is I'm going to give you a magnitude and a direction, and we're going to write our vector in component form.